Hello, Math 2B. This is Roberts, and we have it's a two-page packet, front and back side. The first two pages are notes, and how this is going to work is I'm going to demonstrate a problem on the left-hand side, and then give you some problems to practice with on the right. So on the left-hand side, I'm looking for your complete notes. Make sure you get all these things down, and then on the right-hand side, I'll be verifying the accuracy of your answers. So the first thing I want to do is we're going to practice finding the equation of a parabola when given some points on the Cartesian coordinate plane, some specific points. So I've written here, find the equation given points, but the points I'm going to give you are the roots and the y-intercept. So for the example we're going to do together, I'd like for us to highlight the following points. Let's go ahead and put a dot at -2, 0. So one of my roots is at -2, 0. The other point is at 5, 0. So those are my roots. And it's pretty easy for me to come up with a parabola that's going to have those roots, and we've done that many times. But I also want this parabola to have a y-intercept at -5. So we'll be able to verify this by using our graphing calculator and seeing that we really have created the parabola that goes through those roots and that particular y-intercept. So let's go ahead and start with a note. So the first thing I want us to write down is that we're going to be using the equation y equals a, and then times the quantity of x minus b times the quantity of x minus d, where x and d are the x values for the x, or they're the x values of the x-intercepts. They're the roots. So I can plug in a lot of things pretty easily, right? I can easily write down y equals a, and then I know one of my roots is at -2. So for this one, x is -2, so I'm going to write down a minus -2. So instead of writing minus -2, I'm going to write plus 2. And the other one I'm going to write down is x minus a positive 5, right? So we're going to do x minus 5. So far, this, if a is equal to 1, I know this parabola at a minimum will go through those 2 points. The question is, will it also go through this particular point? And I think not. So how do we find the value of a that'll force it to go through that point? And when we did these last time, what we decided we were going to do was just take the x and y value from the y-intercept. And I could use any point other than the roots, but we're going to go ahead and use this one. And for this point, we know that x is 0, and we know that y is at -5. And it's fairly convenient. What we're just going to do is we're going to plug in this x and this y into this equation. So I'm going to write down y, which is -5, right? And that equals a, which we're trying to find. And then we're going to go ahead and write, because x is 0, this is easy. This is going to become 2. And because x is 0, this is going to become -5. So this equation collapses down to -5 equals a times -10. And to solve for a, I'm just going to divide both sides by -5. So when I do that, or I'm sorry, by -10, I get that a will equal -5 divided by -10. And if I simplify that, I know that a is equal to the number positive 1/2. So that's it. If I want to write the equation down of that parabola, I can pick several different forms, but I'm going to go ahead and write it in this form first. Oops, I do not want my mail client to start. It is y equals, and then it's just going to be 1/2 times x plus 2, and then times x minus 5. So let's go ahead and graph that and verify that it does hit the points that I claim it does. So I'll bring the graphing calculator up here, and I'm going to go ahead and, you know what, it's a good idea because my Honors Math 1 class is using these a lot. So if you're using a class calculator, it's probably a good idea to press second. So I hit the second key and then plus, and then 7, 1, 2. And it'll say reset all RAM cleared. So second plus 7, 1, 2 will make sure that it's set back, and a lot of the statistics plots that they've been using will be gone then. So I'm just going to graph this function. I'm going to press y equals, and the function is going to be 1/2. I think I'm going to go ahead and choose to use the fraction key, or the fraction template. So I'll go 1/2. And again, to grab that fraction template, I press alpha, and then it's F1 where it's at. So it's alpha and then this y equals. So y equals 1/2, and then open parentheses x plus 2, and then close the parentheses, and then x and minus 5. So if I press graph now, I can see this, and it certainly looks like it's doing all the things that I think it's doing, but I can verify that by I can press trace, and with trace on, I can go ahead and hit some values. So for example, when I enter the number -2, I want you to know that it see that it gives me y is 0 there. So definitely, it's definitely found this point correctly, right? When x is -2, it's definitely giving me 0. If I enter 5 for x, you can see it's also giving me that y is 0. So I'm hitting the two roots. And the other point that it should go through is when x is 0, right? It should go through -5. So when I press that, you can see, yeah, when x is 0, y is -5. So this is the parabola that's producing this. One of the things that probably would be good to do is to write this by expanding, multiplying x plus 2 times x minus 5, and then distributing this 1/2 to all the terms. But I'm just going to leave that as optional today. So here's the problem that I want you to do next to this, and you can use what we just did as a model. The points that you're going to use are -7, 0. So at -7, 0, you're going to have a point at that would be 3. So the other root is going to be at 3, 0, and then finally I want you to have a y-intercept up at 5, 6, 7, 8, and 9. Right here at 9. So using those 3 points, I want you to find the equation of the parabola that will hit those perfectly. And you'll know you have it when you go ahead and enter the equation that you get into your calculator and verify that it is hitting. When I put in -7, it should give me 0. When I put in 3, it should give me 0. And when I put in 0, it should be going through 9. The other thing that I want on this page for notes, and by the way, you probably should pause the video at this point just to do that one. There is one more problem that's going to be here though, and this is it. So you've probably unpaused it at this point. What I would like for you to do is find the value that needs to be added to complete the square. So I'm going to do 3 examples, A, B, C, and then I'm going to give you 3 to do. So A is going to be x squared plus 4x plus something. B will be x squared plus 12x plus something. And the last one will be x squared plus 7x plus something. So what we've been doing is to set it up so that it is indeed a square, and we're just figuring out the number of unit tiles needed to complete that square. We're taking whatever the coefficient of x is, and we're dividing that into 2 groups. And just kind of in general, we're building an area model where half of them are off to the left, half of them are up above, And then this value right here is the one that we're finding. So if I was going to do this with not algebra tiles, but just an area model, I could write here's x squared, and then I would put 2x's here and 2x's here. So that's me taking half of those. Now if I, half of the 4. Now if I factor out the greatest common factor, I can see that this is clearly x, and going down this is x. And then this, x times 2 is x, and over here I've got a 2. And you can see I end up multiplying 2 times 2. That's why this is the 2 squared, or 4. So I need to add a 4 here. So just, again, this is just half of the thing I've highlighted in yellow squared. Let's look at B also, though, as an area model. So if I look at this, down here I've got the x squared, and then I've got 12 x's, and I'm dividing that into 2 groups. One of them's out this way with the 6 times x, and then the 6 times x. And what will fill this in is going to be 6 times 6, or 36. And you can see the rest of them, right? Greatest common factor is x. Going down, the greatest common factor is x. This must be 6, and this has to be 6. So it is, when I multiply 6 times 6, I do get 36. 36. So again, it's half of this number squared. And then for the final one, yeah, they don't have to be whole numbers. You can break them off into 2 groups, even if it's an odd number. The other 2 were evens. And at this point, I'm just going to write it down. Hey, this is half of 7, right? 7 halves. And if I square that, right, 7 squared is 49, and 2 squared is 4. So what I need to add to complete this square is 49 fourths. Okay, so let me have you do 3 examples, or 3 problems on your own over here. So we'll look at A, B, and C. So again, same directions. Find the value that needs to be added to complete this square. And the 3 problems I'm going to give you are x squared plus 10x plus something, x squared plus 8x plus something, and then x squared plus, we'll do 5x plus something. Okay, so go ahead and complete this, and then go on to the next video when you're ready to do the back side of the page.